Our next speaker will be Tom Waters, speaking about Clips landing site at a young thrust fault scarp cluster.
Yeah, thanks. And Caleb just did a great job kind of introducing the importance I think tectonics has become for the moon. Said without beating the drum too hard, it has been largely overlooked, but I think now we are starting to see that tectonics is a really important component of our understanding of the moon. So yeah, we're going to propose, and I want to acknowledge my co-authors here, proposing that we land near one of these young thrust fault clusters. Next slide. So these young thrust faults were really largely unknown. They were only a few found in the highest resolution Apollo era imaging, mostly in the Apollo panoramic camera photographs. But their global distribution was really unknown until we got to the moon with LRO and LROC and the NAC, which was capable of observing these small fault scarps. And you can see from the map in the lower right there, they are everywhere on the moon. We now know there are thousands of these very young thrust fault scarps. And we know they're young, not only because of their small scale and their pristine appearance, but also because of their interaction with very, very small diameter impact craters. So next slide. So if these faults are currently active, they're going to produce moonquakes. And fortunately, we had the Apollo seismic network operating for the period shown there and detected 28 shallow moonquakes, some with Richter equivalent magnitudes of up to 5. But we really didn't know what the source of these shallow moonquakes were. But now, based on reanalysis and the locations of the epicenters of those shallow moonquakes, we now believe that some of these young scarps are in fact the source of these small, these shallow moonquakes. All right, and they're probably being formed, or could be being formed, by new fault scarps being formed, or slip events on existing thrust faults. Next slide. So let's talk about the landing site we're proposing. It's the Korolev cluster, and clusters are collections of these scarps. In this case, this cluster is outside the Korolev basin. It consists of more than 20 individual scarps that extend about 140 kilometers in length. It's a far side location. Sorry, I don't have enough decimal points there. That location, what we'd like to do is set down near the footwall of one of these thrust fault scarps, and we've picked one here as an example. And one of the reasons why is that it has access to a boulder field that Caleb was talking about that exists on the wrinkle ridges. And they also occur on some of these low bait thrust fault scarps. From the slope map here in the center, you can see that there are areas, there are multiple areas, again, where the slopes are low enough that a rover would have a reasonably good chance of traversing one of these. The other really importance about this site is it's near the tidal axis of the moon, and this, from our current stress models, is where the compressional stresses peak. So this is kind of where we would expect enhanced activity on these very young faults. Next slide. So what are the science objectives? Well, it's to determine, as Caleb said, we really want to determine if these young thrust faults, or even the wrinkle ridges, these reactivated ancient wrinkle ridges, are potentially sources for the shallow moonquakes. We'd like to determine the frequency and magnitude of shallow moonquakes on the far side. We'd like to do a direct characterization of one of these fault scarps and examine directly any secondary structures we find. We want to explore the subsurface to determine the nature and specifically the geometry of the underlying fault. We'd like to determine the effects of slip events on these faults by looking at exposed, fresh, and or redistributed boulders and regolith. And we'd like to characterize, again, just help to characterize the seismicity of the far side. Also, with the idea of assessing the seismic hazards that these thousands, again, of young thrust fault scarps may represent. Next slide. So capabilities are, we need a lander that is capable of deploying and supporting a rover. And of course, it'll have to have the power and communications support, as well as be able to support an instrument package. Enhanced capabilities, as Clive said, is really the ability to survive the lunar night, because we're going to want to be around long enough with, as these instrument packages detail, with seismometers, both long and short period, to be able to detect a shallow moonquake or multiple shallow moonquakes. And we're going to want imaging systems, of course, wide and narrow angle cameras. The rover is going to have to be capable of traversing slopes up to 10 to 15 degrees. So, and we would need to be able to travel distances of at least 3 to 5 kilometers. And again, enhanced capability would be for that rover to be able to return to the lander and somehow could be configured so it could survive multiple lunar nights. And the instrument on the rover, the principal one, would be a multi-frequency ground-penetrating radar and, of course, imaging system. Next slide.
Oh, Thomas, your 5 minutes have gone up. We'll have to move to the next speaker.
Okay, no, go right ahead. And this traceability is just to show you that again, lunar tectonics has become, I think, an important aspect of lunar exploration. Thank you.